Hello and welcome back. Today we'll be doing question 1 from the 1998 Step Paper 2. Let's get started. Question 1. Show that if n is an integer such that n minus 3 cubed plus n cubed equals n plus 3 all cubed, then n is even and n squared is a factor of 54. Deduce that there is no integer n which satisfies the equation star. Show that if n is an integer such that n minus 6 all cubed plus n cubed equals n plus 6 all cubed, then n is even. Deduce that there is no integer n which satisfies the equation double star. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started. If we expand this first section, then we get n cubed minus 9n squared plus 27n minus 27 plus n cubed equals n cubed plus 9n plus 27n plus 27. Collecting like terms gives n cubed minus 18n equals 54. We can simplify this to n squared times n minus 18 equals 54. Now, as both n squared and n minus 18 must be integers, we have that n squared must divide into 54 as required. Now, if n is odd, then n squared and n minus 18 are odd. So n squared n minus 18 would be odd, which is not possible. Therefore, n must be even as required. Now, n squared is greater than 0, and 54 is also greater than 0. So we require n minus 18 greater than 0, and therefore n is greater than 18. But then n squared must be at least 18 squared, which is 54. So n squared cannot divide into 54, a contradiction. Therefore, there does not exist an integer n such that n minus 3 all cubed plus n cubed equals n plus 3 all cubed, as required. Now we'll move on to the second half of this question. The second half of this question is done pretty much identically to the first half. So, expanding and then simplifying gives n squared n minus 36 equals 432, and therefore n squared divides into 432. This is not required, but it is very helpful for the rest of our proof. Now, if n is odd, then n squared and n minus 36 are odd, and therefore their product would have to be odd, which is impossible because 436 is even. Thus, n must be even, as required. As before, we have n squared greater than 0 and 432 greater than 0. So we require n minus 36 to be larger than 0. So n is greater than 36. But then n squared is greater than 36 squared, which is greater than 30 squared, which is 900, which is far greater than 432. So n squared cannot divide into 432, a contradiction, meaning that there does not exist an integer n such that n minus 6 all cubed plus n cubed equals n plus 6 all cubed, as required. And that's our answer. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.